The first question says simplify fully. So we have this algebraic fraction. We have a quadratic equation in the numerator and denominator. In the numerator, as you can see, we have difference of perfect squares, which means we can use the formula a squared minus b squared equals to a minus b times a plus b. So over here, that's going to be 2x whole square minus 5 whole square, which is equal to 2x minus 5 times 2x plus 5. Now for the denominator, we have 6x squared minus 11x minus 10. We multiply the coefficient of x squared with the constant, so that's going to be 60. Now we find factors of 60. 6 times 10, 60 times 1, 20 times 3, 30 times 2, 12 times 5, and 15 times 4. So now we have to choose that sort of factor which when added or subtracted gives us the middle term, which is 11. So since 15 minus 4 is 11, what we're going to do is we're going to replace the middle term with negative 15x plus 4x, because if we solve it, that's equal to negative 11x. So we can easily replace it with these two numbers. And now what we will do is we will factor by grouping. We divide the equation into two groups. First two terms make a group and the last two terms make another group. So that's going to be 3x bracket 2x minus 5 bracket close plus 2 bracket 2x minus 5 bracket close. Now we can see that between 3x and 2 we have 2x minus 5 common. So we take that common. In the other bracket, we'll have 3x plus 2. And now we can rewrite this fraction as 2x minus 5 times 2x plus 5 divided by 2x minus 5 times 3x plus 2. As you can see, the 2x minus 5 can get cancelled out, and we're left with 2x plus 5 over 3x plus 2. And that is your final answer. Next question says, shown is the graph of the function y equals to f of x. Sketch the graph of f of x plus 1 and f of negative x. So f of x plus 1 means we will shift the graph 1 unit to the left. So that means 4 comes at 3 and this 0 comes at negative 1. So it's going to be like this. That is f of x plus 1. Then f of negative x means that we're going to reflect this in the y-axis. So when you reflect this in the y-axis, this 4 comes at negative 4. This is f of negative x. This is a formula for the area of a regular hexagon with the side length x is given as area equals to 3 over 2 times root 3 times x squared. Prove this formula. So let's begin with drawing a hexagon first. So a hexagon, and as you can see, when we divide this, we have 6 identical triangles, and these lengths are given as x. So if we divide this over here, so as you can see, we have 6 triangles over here, which means each of these angles are going to be equal to 60. So if I draw this triangle over here, so this angle is 60. So if we divide this by 2, that means this is going to be 30, which means this is going to be 60 and this is 90. So it's one of the special triangles, 30, 60, 90. So for the special triangles, the ratio of lengths are, since this total was x, so this would be x over 2 and this would be x over 2. Since this is x over 2, this is going to be x, because it's going to be twice of x over 2. And this will be x times root 3 over 2. Because in a special triangle, where ratios are like this, this is 30, this is 1. This is 60, that's root 3. And if this is 90, that's 2. So using the same ratios over here. And as if you find the area of one triangle, area would be 1 over 2 times base, which is x, and height, which we've determined to be x times root 3 over 2. So that's equals to x squared root 3 over 4. So since we have to find the area of 6 identical triangles, to find the area of the entire hexagon, that's going to be area of 6 triangles. 6 times x squared root 3 over 4. That's going to be 3 root 3 over 2 x squared, which is exactly what they wanted us to prove in the question. The next question says that the straight line L1 has equation 3x plus y minus 1 equals to 0. The straight line L2 is perpendicular to line L1 and passes the point A2. Find its equation in the slope-intercept form. So first, let's convert L1 into slope-intercept form. That's going to be y equals to negative 3x plus 1. Gradient of L1 is negative 3. So to find gradient of L2, we use the equation m1 times m2 equals to negative 1, because that is the condition of perpendicular lines. So negative 3 times m2 equals to negative 1, and m2 equals to 1 over 3, which means y equals to 1 over 3x plus c. Now we substitute the point in this equation. So 2 equals to 1 over 3 times 8 plus c. 2 minus 8 over 3 equals to c. So that's going to be 6 minus 8 over 3, which is going to be negative 2 over 3 equals to c. So y equals to 1 over 3x minus 2 by 3. That is your equation.